Something's broken in prod. Users can't check out. Now, if you work in software, just hearing those words probably makes your heart rate spike, right? It's that dreaded late-night Slack message signaling a catastrophic production failure. And the worst part? It usually happens right after a deployment that supposedly worked. I mean, the code compiled, the pipeline was totally green, the rollout finished without a hitch, and yet, no one can buy anything.
Picture this. It's last Tuesday, 11 p.m. The stakes are incredibly high, the urgency is just palpable, and your team is frantically jumping on a Zoom call to figure out what went wrong. We have all been there, sharing in this exact collective deployment trauma. But here's the kicker. 20 minutes into the frantic troubleshooting, someone finally uncovers the truth. It wasn't actually a bug in the new code itself, no way. It was how the code was introduced to the wild.
Welcome to this explainer. Today, we're going to transform that default, highly stressful process of deploying software into a strategic, intentional decision. We are diving into the 4 pillars of software deployment strategy. Now, most engineers know the names of these strategies, sure, but far fewer can clearly explain exactly when to use which or what the actual failure mode of each looks like when things inevitably go sideways in production.
So here's our roadmap for today. Part 1, the 11 p.m. prod nightmare. Part 2, strategy 1, recreate. Part 3, the rolling update trap. Part 4, blue/green and canary deployments. And finally, Part 5, how to choose wisely. Think of this as your precise toolkit for preventing those catastrophic deployments.
Okay, let's jump right into Part 1, the 11 p.m. prod nightmare. What actually went wrong?
Let's uncover the invisible culprit behind that late-night outage. The deployment technically worked and the rollout completed, so why did everything just fall apart? Well, the system crashed because half of your fleet was running version 1 of the payment API and the other half was running version 2. The critical error, version 2 didn't speak version 1's language. Literally nobody on the team thought about what happens when both versions of the API are alive and serving traffic at the exact same time. It's a classic deployment strategy problem. And honestly, it usually only bites you once, because after experiencing this level of pain, you never forget to plan for it again. So let's fix that right now.
Moving to Part 2. Strategy 1, the recreate approach. Stop everything.
Let's look at the first of our 4 deployment pillars. We're starting with the most basic, but sometimes absolutely necessary approach you can take. The recreate strategy is exactly what it sounds like. Stop everything, deploy the new version, start everything back up. And I really want to emphasize here, the application going completely offline between shutdown and startup, that is entirely intentional. Recreate forces a hard, clean cut between your old version and your new version, zero overlap.
The advantage of this approach is pretty obvious, right? It's incredibly simple to understand and implement. But the glaring downside, for sure, is guaranteed downtime. Every single deployment means your users get a lovely little error page while you ship. But here's the crucial point. Sometimes this is genuinely your only option. If your new database schema fundamentally breaks the old application, you physically cannot run both versions at the same time without completely corrupting your data. So this strategy is best reserved for dev environments, internal tools, batch jobs, basically anywhere that a few minutes of downtime is just annoying, rather than, business ending.
All right, Part 3, the rolling update trap, also known as the Kubernetes default.
Let's shift to what is easily the most common strategy in modern software. A rolling update gradually replaces old instances with new ones. If you're using Kubernetes, it takes down one pod, starts a new one, waits for it to be healthy, and then seamlessly moves on to the next. The magic here is zero downtime. Traffic keeps flowing continuously. This is actually the Kubernetes default because it handles stateless services brilliantly without requiring a single piece of extra tooling from your team.
But, and this is a big but, here is the hidden flaw in this process that nobody tells you about. During the rollout, you are running version 1 and version 2 simultaneously. For several minutes, user requests are randomly hitting the old version and the new version. If your API changed in a way that isn't backward compatible, or if your new version expects data formatted in a way the old one doesn't produce, you get spectacular failures. And these bugs are genuinely a nightmare to debug because the code works perfectly when you test it locally. It only breaks when the two versions try to talk to each other in production. That is the trap.
Which brings us to Part 4, blue/green and canary, the advanced strategies.
Now we're getting into the heavy hitters. These advanced strategies are designed specifically to minimize risk and reduce the blast radius for high-stakes environments. The blue/green strategy utilizes 2 totally identical production environments. So right now, blue is live and serving 100% of your user traffic. You deploy your brand new version to the green environment, you run all your tests in green, and when you are absolutely 100% confident it works, you flip the traffic switch. 1 second blue serves everything, the next second green does. The massive advantage here, instant rollback. If something goes wrong right after the switch, you just flip traffic back to blue. It takes seconds, giving your team immense peace of mind.
However, we have to contrast that incredible speed of recovery with the strict realities of this strategy. You are literally paying for double the infrastructure for the entire duration of the rollout. Furthermore, databases get very complicated. Do blue and green share a database? What happens to user rights that came in exactly after you switched? These aren't unsolvable problems, but they require serious intentional engineering effort. Blue/green is really best for high-stakes releases and strict compliance environments where a rollback in under a minute is a hard business requirement.
Moving on to our fourth pillar, the canary release. The name actually comes from coal miners. They'd bring a literal canary underground before the main crew went in. If the canary died, it meant there was toxic gas and they needed to clear the mine immediately. It is a pretty visceral analogy, but it perfectly explains the concept, testing for toxic conditions with a very small sample before sending the whole crew in.
So applying this to our software, you deploy your new version to just a tiny slice of production, let's say 5% of your traffic. You watch your metrics like a hawk. If the canary is fine after 15 minutes, you progress to 20%, then up to 50%, and finally you push to 100%. The absolute beauty of this progression is that if something fails catastrophically at step 1, 95% of your users are blissfully unaware there was ever a problem. Real production traffic validates your release before it reaches everyone. But I have to warn you, canary releases require some heavy lifting. You can't just guess here. You need a smart load balancer or a service mesh capable of precisely splitting traffic by percentage. And more importantly, you need real observability. If you do not have dashboards that explicitly compare the experience of that 5% against the other 95%, you aren't actually doing a canary release. Actually, scratch that. You're just doing a really slow rolling update with extra steps. Canary is best reserved for high-traffic applications where a bad deploy would be truly catastrophic. Think Google or Netflix scale.
Finally, part 5, how to choose wisely, picking the right tool for the job. I want you to take a mental snapshot of this master framework. It perfectly aligns the problem with the correct tool. Recreate is your go-to for internal tools and dev environments. Rolling updates are ideal for stateless apps and most everyday microservices. Blue-green is your heavy hitter for high-stakes, compliance-heavy releases, and Canary is your ultimate safeguard for high-traffic, highly risky deployments.
And this brilliantly illustrates how teams should actually progress through these strategies. Think of it as a graduation path or climbing a mountain. Start with rolling updates. It's the default for a reason. Add blue/green only when your need for instant rollback speed outweighs the pain of infrastructure cost. And finally, graduate to Canary only when your scale demands it and your observability metrics are mature enough to actually learn something from that 5% traffic slice.
So I'll leave you with this final, somewhat provocative thought. Are you proactively choosing your deployment strategy, or are you just letting Kubernetes choose it for you? Because most teams doing rolling updates right now are doing it simply because they ran kubectl-apply and the system picked it for them. The team at 11 p.m. wasn't doing anything maliciously wrong. They just hadn't thought through what gradual rollout meant at the API layer. But once they did, they added versioned API paths and solved the trap for good. Intentionality is what truly separates average engineers from great ones. Knowing what your team is doing and exactly why they're doing it is half the battle. Thanks for joining me on this explainer, and I'll see you next time.